Welcome to the Python logging crash course. In this course, we start with why logging is better than print and how it solves problems with levels, formatting, and saving logs. Next, we learn the basics of using a logger, setting levels, and writing first log messages. Then, we configure logging with basic config, handlers for console and file, and custom formats with timestamps and levels. Finally, we practice real project use with per-module loggers, different levels for development and production, log files for audits, and an example app with multiple loggers. Why login instead of print? Problems with print for debugging. Most beginners start debugging with print statements. While this is fine for small scripts, it quickly becomes a problem in real projects. Print has no way to show how important a message is. You cannot easily disable or filter messages once the program grows. There are no timestamps, so you cannot know when something happened, and print gives no extra context about the source of the message. This makes it very hard to debug and maintain software at scale. That is why we need logging. What logging solves? Logging is designed for real software development. It provides different levels such as debug, info, warning, error, and critical. This makes it possible to separate detailed development messages from important production issues. Logging is easy to enable or disable without changing the source code. You can format logs to include timestamps, log levels, and even module names. Logs can also be written to files for later review. This makes it easier for teams to trace issues in production systems and keep audit records. Basic logging flow. To understand logging, think about a flow. A logger is the object that creates log messages. Then a handler decides what to do with those messages. Finally, the output is where the messages are sent. This can be the console, a file, or even an external system like a monitoring service. Separating these steps makes logging flexible and powerful compared to simple print statements. Here is a simple comparison between print and logging. First, using print, we just write 3 messages. The output shows the text exactly as we wrote it, but with no extra context. Now let's use logging. We import the logging module and configure it with a basic setup. Notice the same 3 messages are written using logging.info. The output now includes the log level, which is info, and also the source, which is root. Logging automatically adds this context without extra work. This makes debugging and analysis much easier, especially in large applications. Basic usage of logging.logger. Importing and creating a logger. To start using logging, you must first import the logging module. Then you create a logger object by calling logging.getLogger. It is common to pass _name, _, so that each module in a project has its own logger. This makes it easy to track where messages are coming from when working in bigger projects. This code imports the logging module and creates a logger using logging.getLogger with the name of the module. _name, _ tells Python to use the current module name. Use 1 logger per module to make log output traceable across a project. Setting logging level. Log levels control which messages are shown. The most common levels are debug, info, warning, error, and critical. By default, only warnings and above are displayed. If you set the level to debug, you will see everything. If you set it to error, you will only see errors and critical issues. This helps filter the output for different environments, such as development or production. In this example, we set the logger level to debug. Then we log 5 messages, 1 at each level. Depending on the configuration, some messages may not appear. By default, Python shows warning and higher. so debug and info will not be displayed unless we change the handler configuration. Setting the logger level to debug means the logger will accept messages at debug and above. Accepting a message means the logger will try to handle it, but it does not guarantee the message is printed. Handlers decide what actually gets output. If a logger has no handlers, messages propagate to the parent logger up to the root logger. The root logger's default configuration prints only messages at warning level and above. Because this code does not add any handler or call basic config, the default handler is used, and that filters out debug and info. In this example, we call logging.basicconfig. This is the quick setup function that adds a handler to the root logger. We pass the argument level equals logging.debug. This tells the root logger to accept and print all messages starting from debug and above. Without this call, the root logger only prints warning and higher, which hides debug and info. We also pass a format string, so the output shows the level name followed by the message. Then we create our own logger with logging.getLogger, _name, _, and set its level to debug. This means the logger accepts all messages. Because the root logger now has a handler configured at debug, the messages are not filtered out. Without basic config, debug and info are hidden by the default handler. With basic config set to debug, all levels are displayed. This demonstrates the difference between the logger's acceptance level and the handler's output level. Writing first log messages. Once your logger is set up, you can start writing messages. Use logger.debug for detailed technical information. Use logger.info for normal updates, such as starting a task. Use logger.warning, error, or critical for problems of increasing severity. By default, these messages appear in the console. Later, we will learn how to send them to files or other outputs. In this example, we configure logging with basic config setting the level to info. Then we create a logger and write 5 messages, one at each level. The output shows that info and higher levels are displayed. Debug is hidden because the minimum level is info. Notice how each log line shows the level, the module name, and the message. This is much more useful than plain print statements. In this example, because we did not call setLevel on this logger, it inherits from the root logger. That means it follows the root level of info. The key lesson is that both the logger level and the handler level control what appears. Here the handler created by basic config is at info, so debug is not printed even though the logger accepted it. Configuration and handlers. Using basic config for quick setup, Python provides a function called basic config for quick setup. With it, you can define the log level, the format of the messages, and even send the output to a file instead of the console. This is very useful for small projects, scripts, or demonstrations where you just need a simple configuration. In this code, we call logging.basicconfig. We set the level to debug and define a format that includes the timestamp, the log level, and the message. When we log 3 messages, the output now shows each one with a date and time. This simple setup makes the logs more professional and useful. Adding handlers. Handlers decide where your log messages go. The console handler prints logs to the screen. The file handler saves logs into a file. You can add more than one handler to a logger, so the same message can go to the console, a file, or even a remote system at the same time. This makes logging flexible for both development and production use. In this example, we create a logger with logging.getLogger, and we name it my_app. You call logger.setLevel with logging.debug. This means the logger will accept all messages from debug upward. But remember, the logger does not print anything by itself. To actually see output, we need handlers. We now create a console handler with logging.streamHandler. This handler sends log messages to the terminal. We set its level to info. This means the console handler will ignore debug messages and only print info and above. Then we create a file handler with logging.fileHandler, pointing to a file called app.log. We set its level to debug. This means the file handler will write everything, including debug, info, warning, error, and critical. After that, we attach both handlers to the logger with logger.addHandler. Now the logger sends every accepted message to both handlers. Each handler then applies its own filter before output. Now we send two log messages. The first one is logger.debug. The logger accepts it because the logger's own level is set to debug. The console handler ignores it because its threshold is info, but the file handler allows it because its threshold is also debug. So the debug message is written into the log file only and nothing appears in the console. The second one is logger.info. Again, the logger accepts it. This time, both handlers allow it, because info is equal to or higher than their thresholds. So the info message is printed on the console and also written to the log file. The important lesson is this: each handler has its own filter. A single logger can forward messages everywhere, but the handlers decide what actually gets shown or saved. This way, you can keep console output short and useful, while still storing full details in a log file. Customizing log format. You can customize the format of logs to include more context. Common fields are ask time for timestamp, level name for log level, name for the logger name, and message for the actual log text. You can also add module name, line number, process ID, or thread name. This makes it easier to trace exactly where each log comes from. In this example, we configure a custom format. It shows the timestamp, the logger name, the log level, the line number, and the message. The output is very detailed and helps developers quickly locate problems in the code. Practical use in projects. Organizing loggers per module. In real projects, applications are split into multiple modules. A good practice is to create one logger per module, using _name, _. This way, the log output tells you exactly which module created the message. In large systems, this makes debugging much easier because you can filter or search logs by module name. Here we have two files, module_A and module_B. Each one creates a logger using _name, _. When they log messages, the module name will appear in the output. This tells us exactly where each log line came from. Using different levels. Log levels are very useful to reduce noise. In development, you often want detailed debug and info messages to trace what the program is doing. But in production, you only want warnings and errors, because too much logging can make logs hard to read. By adjusting the level, you control how much information is displayed without changing the source code. In this code, we first set the level to debug, so the debug message appears. Then we switch to warning. Now, the info message is ignored, but the error message is still shown. This simple change allows us to adapt logging for different environments. Redirecting logs to files for debugging or audits. Another common practice is writing logs to files. This is essential in production systems, where you need to keep a history of errors and important events. These log files can be used for debugging issues after they happen, or for audit purposes to track what the system did. In this example, we configure logging to write into a file called app.log. The format includes a timestamp, the log level, and the message. When we log 3 messages, they are written to the file named app.log instead of the console. This is a standard way to collect logs in real projects. Now let's see a simple application with multiple loggers. Each module defines its own logger. All messages are written into a single file with clear levels and formats. This setup scales well as the application grows. In this example, we have 3 files. The main file configures logging with basic config, writing all messages into project.log. Module_A and module_B each have their own logger. When the application runs, all messages are collected in one file with the module names included. This gives us a complete view of what happened and where each message came from.
Thanks for watching.